Welcome to page 2 of the practice test for Unit 8 circles. And the directions were a little messed up on this one. Something got kind of cut out when I went to print these. This should be question number 6 should say find x, and then find the perimeter should actually be over there for question number 7 off to the right. So knowing that makes this a little bit easier now. So number 6, we see circle O with a diameter drawn, and we see a segment across the bottom that is a tangent, and we know that a tangent and the radius are always perpendicular, so that means that's going to be 90 degrees, and that's going to give me a right triangle, and 90 plus 51 plus x makes up a triangle, so it has to add up to 180. So just doing a little subtraction on both sides. Subtracting 90 and 51 from 180 leaves me with 39 degrees for x. All right, number 7 wants us to find the perimeter. So it says that QT is 12.5. which means QU is also 12.5, because we know that from any point outside of a circle, any two tangents from the same point are always equidistant. It says that PT is 19.7, which means PS is also 19.7. And it says that SR is 33.6, which means UR is 33.6. And then it wants us to find the perimeter of that triangle. So the perimeter here is the sum of all 6 of those numbers. And if I were to add them all up, it would add up to 131.6 units long to be that perimeter. All right, jumping down, number 8. Number 8's got a lot going on here. It says AB is tangent to circle C, and it wants us to find that radius. Well, because I know that I have a tangent and a radius, I know that that must be a right angle. So I can do A squared plus B squared equals C squared. You have to make sure that you're careful here, that the hypotenuse is also is always your C value, and A squared plus B squared equals C squared. All right, in the Pythagorean theorem, the hypotenuse of the triangle must be C. So my two legs, R and 20, so R squared plus 20 squared has to equal the hypotenuse, which is 25 squared. Subtract 20 squared on both sides. So R squared is 25 squared minus 20 squared, which is 225. And then R would be the square root of 225, which is 15. So R must be 15. Number 9, the arc length of an arc in a given circle is 12 pi. The radius is 8. Find the measure of the arc in degrees. All right, well, I'm going to draw a little circle over here. Let me give my center. Okay, and it wants me, it says the length of an arc is 12 pi. So it says the radius is 8, and it wants us to find the measure of the arc. So the measure of the arc is going to equal the measure of the central angle. We know those two things are the same. So arc length, the arc length is equal to the angle measure out of 360 times the circumference. Well, what is the circumference of this? Well, first of all, the arc length I know is 12 pi. The angle is what I'm looking for. And the circumference is going to be pi times diameter. Well, if the radius is 8, then the diameter is 16 pi. I'm going to clean that fraction up a little bit, and I can say that 12 pi is equal to 16 pi times theta, all out of 360. I'm going to divide both sides by pi, so the pi's will cancel. I can multiply both sides by 360, get rid of the 360, and then I can divide both sides by 16 to get rid of the 16. So to find theta, I have to do 360 times 12 divided by 16. So 360 times 12 divided by 16. And it's 270. So theta has to be 270 degrees. So if theta is 270, then the arc is also 270 because we set theta to be a central angle. All right, number 10. Find the value of each of the given measures. So number 10, that is an inscribed angle, and an inscribed angle is equal to half of its intercepted arc. So here is the arc that is intercepted. It's 106 degrees. So A is half of 106, or 53 degrees. Number 11 gives us 134 degree arc, a 128 degree arc, and then A. So they all have to add up to 360. So if I do 360 minus 134 minus 128, I should get 98. So A is 98 degrees. And then angle B is an inscribed angle, so it is half of 98, which is 49 degrees. Number 12. Number 12, it looks like we have a tangent line in what appears to be a diameter. And it says it is x degrees. And we know that a tangent and the diameter are always perpendicular. So that must be a 90. And then to find y, I know my first arc here is 182 degrees. And a whole circle must be 360. So 360 minus 182 is 178 degrees. Number 13. I have an inscribed triangle. And I know that I have the arc DE up here is 96. So the inscribed angle is angle F, makes up that 96 degree arc, and an inscribed angle is half of its arc. So if I do half of 96, I should find angle F to be 48 degrees. So this one down here is 48. Then to find angle E, the sum of the angles of a triangle add up to 180. So I can do 180, subtract 55, and subtract 48 to find angle E. That'll give me 77 degrees. And then arc EF. Arc EF is the arc across from inscribed angle D. So inscribed angle D is 55. So the arc across from it must be twice as big as that angle, and 55 times 2 is 110 degrees. So that should be 110. And the final problem has circle O, and it shows that CB is a diameter, which means this bottom arc has to be 180. It's a semicircle. The top arc from CAB should be 180 as well, and I see that from C to A is 70, so that means the other one has to be 110, so it adds up to 180. And now I can just start doing my inscribed angles are half of its arc. So angle C is the first one it wants to know. Angle C is across from 110, so half of 110 is 55. Angle B is across from 70. Half of 70 is 35. And angle A is across from 180, and half of 180 is 90. And that's it for page 2.